I'm not going to show you part A. Hopefully you can work through that. If not, please let me know. But for part B, we want to show that this point P with x-coordinate 3 at which the line tangent to the curve at P is horizontal. There's a lot to unpack here. First off, they just tell us that the x-coordinate is 3, but our derivative uses both x's and y's, so we're going to need to figure out a y value to make this thing work. And to show that the tangent line is horizontal means the derivative is 0. Because that's what the slope of the tangent is. Horizontal line means 0 slope. So basically we need to figure out and show that there is a place when if x is 3, this is going to equal 0. So let's start by trying to figure out what the y values are or could be when x equals 3. To do that, we'll need to go to our original function, which has x's and y's all mixed up together. We know that x is going to be 3. So I'm going to use that. I'm going to go in here and I'm going to say x is 3, so 3 squared is 9, plus I don't know what the y value is or could be. There could be multiple ones. Equals 7 plus x is equal to 3, so we get a 9y. All right. Now let's solve this thing for y. So I'm going to get my quadratic balance to one side is going to equal 0. I'm going to keep my a term positive, so I'll subtract a 9y. I'll subtract 7. I'm going to bet that this is factorable, but I'm going to pause while I factor it. So after some thinking, I factored this into 4y minus 1, y minus 2. I set each factor equal to 0 and solved. And I found that if x equals 3, y could either be 1/4 or 2. So the points I'm looking at are either the point 3, 1/4 or 3, 2. And apparently, for one of these, the slope of the tangent will equal 0. Now, the slope of the tangent is a fraction, and we all know that a fraction is 0 only if the numerator is 0. So really, all I got to do at this point is check to see which one of these points, when plugged into this expression, gives a 0. The 1/4 to me is not looking too promising. I don't want to deal with the fractions anyway, so I'll start with this guy. I'm going to have 3 times that y value minus 2 times that x value, which ends up being 6 minus 6, which is 0. So I don't really care what the bottom is. I mean, I guess the bottom is going to be 16 minus 3 times 3, 9, but who cares? It's 0 over whatever, some non-zero number. The slope is 0. That means the tangent line is 0. So I did it, and the y-coordinate of P is 2. Yeah, that's all there is to that.